Today we're going to be looking at a molecule called cyclopentanone. Cyclopentanone has a carbon ring, a 5-membered carbon ring, with a ketone attached to it. It has a chemical abstract service number of 120-92-3. The molecular formula is C5H8O. We'll have 2 degrees of unsaturation, which I will show you. We'll have the carbon ring, which is 1 degree, and the pi bond, which is another, giving us a total of 2. It has a molecular weight of just over 84 grams, melting point of -51 degrees Celsius, and a boiling point around 130 degrees Celsius. It's a clear, colorless liquid at room temperature. And without further ado, we're going to use this Snatoms kit. Now, Snatoms are interesting in that the white ones are going to represent our hydrogens. The red, of course, is oxygen, black being carbon, and this is going to form our double bond. But Snatoms uses magnets to create molecular bonds, contrary to what we normally have with a stick and ball model kit. This gives you a much more real feel to the molecular structure. It's more natural. The molecules created with the Snatoms kit look and behave more like real molecules. They show the bonds as, for example, they show them as overlapping electron orbitals, which is what they actually are, rather than being connected with just sticks. So without further ado, we're going to create this 5-membered ring. And you can see that when we connect 2 carbons using a sigma bond, you can see how it's free to rotate just as they are. We will create a double bond up here with our oxygen. Creates our ketone. And you can see it lock into place, and it has no free rotation compared to our hydrogens that we put on these carbons, these non-carbonyl carbons. And they're free to rotate. And there will be 2 on each one of these 4 carbons, giving us our molecular formula of C5H8O. Alright, this is, like I said, cyclopentanone. If we look at the sigma bonds, you have a total of 1 with each carbon and hydrogen. That gives you a total of 2, 4, 6, and 8. And you have a sigma bond in between each carbon. So 9, 10, 11, 12, 13. And then our pi bond, or double bond up top, has 1 sigma bond as well, along with the 1 pi bond to make the double bond. The Snatom kit makes everything much easier, gives you a much better representation of the molecule itself. If we look at our carbon hybridization, you see an sp2 carbon here, with these 4 being sp3 hybridized. Talking about the molecule itself, it's a cyclic ketone. As I said, at room temperature, it's a clear, colorless liquid. It has a peppermint-like odor. This is what we consider our carbonyl group up top. It's the CO double bond. Let's talk about the bond angles. The bond angles of the carbon ring are approximately 108 degrees, but there is some ring strain, as the ideal bond angle for this sp2 hybridized carbon atom is 120 degrees. Each of the 4 carbon atoms down here that are not the carbonyl carbon have 2 hydrogen atoms bonded with sigma bonds, and the 4 carbon atoms in cyclopentanone that are sp3 hybridized, they form tetrahedral geometry with bond angles of approximately 109.5 degrees here. So in total, as we said, there are 14 sigma bonds, 1 pi bond, and the ring structure that we see adds 1 degree of unsaturation along with the pi bond of 1 degree. So in total, we have 2 degrees of unsaturation. That concludes our summary of the structure, properties, and molecular geometry of cyclopentanone using Snatoms.